In examples 6 and 7, we are going to look at some problems that involve the other simple interest formula. So you are being told here to use A equals P times 1 plus RT. So we will go through each problem and first talk about why it is a simple interest problem. And then we will also talk about why A equals P times 1 plus RT is easier or better to use as opposed to I equals PRT for the particular problem, and then we will solve the problem. So let's take a look at example 6. It says a loan of $10,000 was repaid at the end of 6 months. What amount, principal and interest, was repaid if a 6.5% annual rate of interest was charged? Okay, first of all, when you read through the problem, why is it simple interest? Well, you do not see the phrase simple interest anywhere in the problem, okay? So how do you know it is simple interest? Well, I told you, if it's simple interest, you will not see the word compounded. The word compounded is not in the problem. That makes it a simple interest problem, okay? So now you are being told to use this formula, A equals P times 1 plus RT, okay? Why is this one better to use than I equals PRT? Well, if you read the problem, it is asking you, if you look at the question, it says, what amount was repaid? Okay, it's talking about like you're making a loan here and you're trying to calculate how much money was paid back at the end of the loan. So that's the principal and the interest. So that is referring to the A value, the total amount repaid for the loan. So that is why it is better to use A equals P times 1 plus RT as opposed to I equals PRT. Okay. All right. So for this particular problem, we are looking for A. Okay, the amount we need to repay, we know that's the principal plus the interest. The formula is going to calculate that for us. So since we're looking for A, we should know the value of P, R, and T. So let's write those down. P is going to be how much money you borrowed, the principal. So that's going to be $10,000. Okay. R is going to be the interest rate as a decimal. So drop your percent sign and move the decimal point 2 places to the left. So we're going to get 0.065. And then time has to be measured in years. You're borrowing the money for 6 months here. So remember, you're going to use 6 out of 12 months. Okay. If you just used 6, that would be referring to 6 years. Okay. Remember, when you do the calculation, you can plug in time equals 6/12. You could also use 1/2, the fraction reduced. You could also use the decimal 0.5. Okay, they're all equivalent. It is not necessary to reduce the fractions when you're doing this stuff. Okay, so let's go ahead and plug everything in. Okay, so you're going to get 10,000 times 1 plus 0.065 times 6 over 12. Okay, and then we're just going to plug this into the calculator just like you see it. So let me get my calculator. All right, so here we go. Okay, so we're going to get, just plug it in just like you see it. Okay, very straightforward. Okay, so we're going to get 10,000 times, use your parentheses, okay, 1 plus 0.065 times 6 divided by 12, close parentheses. Okay, and there you go. Okay, this is a nice even number, no cents, so it's going to be $10,325. Okay, remember you need to put units, okay, when you're answering your questions. So this is going to be $10,325. Okay, again, anytime you finish a problem, you want to ask yourself, is this logical? Does this number make sense? Okay, so remember, you borrowed $10,000 here, and you borrowed it for 6 months, so not a very lengthy period of time. So how much do you repay? This number makes sense. It is bigger than $10,000, and it's not too much bigger than $10,000. Okay, so that is a sensible answer. again, there are lots of extensions with this. I could ask you how much interest was earned, okay? And you could go the I equals PRT route if I asked you that additional question and calculate it that way. But remember, you can do simple things like take the $10,325 and subtract out the principal of $10,000 and realize that $325 worth of interest was made, okay? So there's all kinds of extensions with these problems. All right, moving on to example 7. Okay, it says a check for $3,097.50 was used to retire a 5-month $3,000 loan. What annual rate of interest was charged? Okay, so here's our question. Okay, again, first thing we're going to address is why is this simple interest? Okay, it does not state the phrase simple interest in it, but it lacks the word compounded. So that makes this a simple interest problem. Okay. Again, you are told to use the formula A equals P times 1 plus RT. Okay. So why is this the better formula to use over I equals P times R times T? Well, let's read the question again. You have a check for $3,097.50. It was used to retire a 5-month $3,000 loan. What annual rate of interest was charged? Okay, first of all, what are you looking for? What annual rate of interest? You are looking for R here, okay? R appears in both formulas, so we need to look at the other numbers that they have given us, okay? So this word retire, if you're retiring a loan, that just means you're paying off the loan, okay? So the check was used to pay off the loan, okay? So if you read this, okay, the amount of the loan was $3,000, okay? So that's going to be your P value, how much money was borrowed, okay? This other value is the A value, okay? This cannot be the interest, okay? The interest, you can't have $3,097.50 worth of interest on a $3,000 loan, especially if it's only for 5 months. That doesn't make any sense. This looks more like $3,000, the $3,000 loan plus the interest that was accrued. So this is the present value, how much money we borrowed, and this is how much we pay back in the future. Okay, so the $3,097.50 is the A value, okay? So that's why it's preferable to use this formula, okay? All right, so we know the P, we know the A, we need to write down we're looking for R, so we need to write down the T value, okay? The money was borrowed for 5 months, so you're going to write down 5 months out of 12, okay? And let's go ahead and plug everything in. All right, so we're going to get $3,097.50, okay, is equal to 3,000 times 1 plus R times T, okay? And then we've got to solve that for the R value, okay? All right, so there's a couple of different ways that you can go about this, okay? The first thing you could do is you could distribute the 3,000. So if we did that, we're going to get $3,097.50 is equal to 3,000 plus, I'm just going to reorder here because we're multiplying, so order doesn't matter. 3,000 times 5/12 times R, okay? And so then this will simplify, okay? These numbers right here will simplify. So you'll get $3,097.50 is equal to 3,000. Okay, I'm going to go to my calculator. I'm going to figure out what 3,000 times 5/12 is. Okay, so that's going to give us $1,250. Okay, so plus 1,250 times R. Okay, and then if we want to solve this, okay, we are going to go ahead and we need to isolate this R. So the first thing we can do is we need to get this thing by itself. Okay, so we're going to move the 3,000 over. Since the 3,000 is positive, we're going to subtract it from both sides. Okay, so we're going to get $3,097.50 minus 3,000. Okay, that's going to give us $97.50. Okay, so that's going to give us this. Okay, that is equal to 1,250 R. Okay, and then if you want R, you need to divide both sides by 1,250. Okay, let me put a little partition here so that we don't run into these variables. Okay, all right, so I'm going to go to my calculator. Okay, put this in. Okay, so we're going to get 9750 divided by 1,250. Okay, and that is going to give us the R value. Okay, so let me write this down. Okay, our R value is 0.078. Okay, remember in the directions, it said if you were solving for an interest rate, and that's exactly what we're doing here. If you're solving for an interest rate, you need to state it as a percent. Okay, so this is, you remember when you work with R in the formula, you input it as a decimal. So when it gets output like this, this is the decimal form. So you need to move the decimal point 2 places to the right and tack on a percent sign. Okay, so the answer to this question is 7.8%. Okay, all right, so in the next examples, okay, examples 8, 9, and 10, we are going to do more practice with our two simple interest formulas, the I equals PRT and A equals P times 1 plus RT. The only difference now is I'm not going to tell you which one to use, okay? You're going to have to figure out which of the two formulas is preferable in each situation,